In this lesson, we will learn how to use StatCrunch to test hypotheses and establish confidence intervals for population means. For our first example, we'll consider a study where researchers wanted to assess how much TV third and fourth graders were watching. So they asked 198 third and fourth graders how much TV they watched per week, and the mean number of hours was 15.4 and the standard deviation was 9.16 hours. We want to know if this data gives evidence that third and fourth graders watch more than 2 hours of TV per day. Note that 2 hours of TV per day translates into 14 hours per week. So what we will do is we'll open up StatCrunch, and under the Stat menu we will pick T-Statistics, One Sample, and we have the summary data, not the individual information for all 198 students, but rather the sample mean, which was 15.4, the sample standard deviation, which was 9.16, and the number of students, which was 198. On the next screen, we're asked to choose between a hypothesis test or a confidence interval. First, let's test the hypothesis that on average, third and fourth graders watch 14 hours of TV per week, versus the alternative that they in fact watch more than that. We're going to hit calculate, and here are the findings. I'm sorry, let's get that back again. We find the test statistic has a t-value of 2.15 and a p-value of 0.0164. This p-value is less than 0.05, so that at the 0.05 level of significance, we're going to decide to reject the null hypothesis and go with the alternative. That in fact, on average, third and fourth graders do watch more than 14 hours of TV per week, with a p-value of 0.0164. If we want to do options and edit, we can change the kind of test we're doing to a 95% confidence interval and calculate. And we find with 95% confidence that on average, third and fourth graders are watching somewhere between 14.1 and 16.7 hours of TV per week, which confirms our decision to reject the null hypothesis that they're watching 14 hours. If you'll notice, all of the numbers in this 95% confidence interval exceed 14 hours. For our next example, we're going to look at a study where a psychologist reports that the mean number of hours that students at his school gets is 8 hours per night. The data from a random sample of 15 students is listed below. We want to test the claim that the average number of hours per sleep for the students at this school is 8 hours per night. In this case, we do not have the summary data, but we have the raw data for this experiment. We actually have this number of hours of sleep for each of the 15 students in this study. To test the hypothesis, we're going to go under Stat, T-Statistic, One Sample, but this time we're going to pick with data. The data is in the column labeled Hours of Sleep, and we want to test that these students are getting on average 8 hours of sleep per night versus the alternative that they're getting something other than 8 hours of sleep per night. We're going to go to Calculate, and here we find that the test statistic, the t-value, is a negative 2.85 with an accompanying p-value of 0.0128. Since the p-value is less than 0.05, we are going to reject the null hypothesis and decide that on average students at this school are not sleeping 8 hours per night on average. Since the t-value is negative, we can in fact conclude that on average students at this school are sleeping less than 8 hours each evening. If we go under Options and Edit, we can then follow it up by a 95% confidence interval by leaving the level set at 0.95, calculate, and we find that with 95% confidence, on average, students at this school are getting somewhere between 5.6 hours of sleep per night and 7.7 hours of sleep per night. You will notice the values in this interval do not include 8. In fact, they are all less than 8, which confirms our decision when we were testing the null hypothesis that on average students at this school get less than 8 hours of sleep per night.